G'day everyone and welcome to another episode of Mr. Code's STEAM podcast where we talk about science and technology after school. Today we're going to learn how to make some amazing 3D printing time lapses with the Raspberry Pi. If you've got a 3D printer, then you've probably tried to make some time lapses already. So you set up a camera or a smartphone in time-lapse mode and you'll encounter this problem. As you can see, it doesn't look really good because the platform keeps moving to a different spot each time the camera takes a photo. Now today, I'm going to teach you how to make these super smooth time-lapse effects where your models look like they are growing out of the middle of your print bed using a 3D printer and a Raspberry Pi. Now I spent a lot of time making these videos, so if they help you in any way, then please leave me a like and subscribe to my channel. It's your support that makes it possible for me to make more videos, so I thank you in advance. Today's video is sponsored by Cura, who have provided me with this huge collection of their new exotic filament. More about them later. So to get started, we need a few things. Obviously, you need a 3D printer. So any Creality or Prusa 3D printer will probably work. So check the link in the description and you will see the list of compatible devices. In addition to that, we have some other things. So let's have a look. So today we're going to use the Raspberry Pi 4B. So any RAM is going to do. So 2 gigabytes, 4 gigabytes, 8 gigabytes. It's all going to be good. And then we're going to 3D print some parts. So this is going to be the camera holder for our Raspberry Pi camera. And then we need a Raspberry Pi camera. So here we have a camera version 2.1. We need an extension ribbon cable. So this is the extension ribbon cable. Now this cable that I'm using is 600 millimeters. So that's going to be enough for what we are using for today. But you can get a longer one if you want to make some fancy camera angles as well. What else have we got? We got this USB connector. So this goes from the USB to a smaller USB connection. So this will attach to your printer. This will attach to the Raspberry Pi. We have a micro SD card. So the micro SD card is the storage for your Raspberry Pi. I'm using a 32 gig version from SanDisk. You need some sort of adapter. So this is just a SanDisk micro SD card to SD card adapter to attach to my computer. If you have a USB adapter, then that's going to work as well. And then finally, I've 3D printed this case for the Raspberry Pi to install onto the printer. And of course, you need the power source as well. So this is my USB-C power source for my Raspberry Pi. Now you don't need to have all the 3D printed stuff. It's just going to make it a lot neater and tidier. And of course I'm going to put the links to the STL files in the description as well so that you can download my exact setup. So the first thing we're going to do is set up our Raspberry Pi. So you go to this link to download the Raspberry Pi Imager. This Raspberry Pi Imager helps you set up the software for your micro SD card so that it loads up the right operating system on your Raspberry Pi. It's very easy to use, so just download it, install it, and run it, and this is what we're going to do. Okay, so we're going to attach my micro SD card to my SD card adapter, and then we'll plug it into my computer and load up the Imager. Alright, once you've got your Imager up, we're going to choose our operating system. So the operating system we're going to use is this other specific purpose operating system. So other specific purpose OS. And then we're going to use Octopi. So Octopi is the operating system that helps you control your 3D printer from your Raspberry Pi. and then we click on this Octopi latest version. Okay, storage. When we're choosing your storage, triple, quadruple check that you are choosing the SD card and not your external hard drive or any other device that is plugged into your computer, because it will completely erase it and you will never be able to get any information back. So double check that you have your SD card connected and not anything else. So you click on your SD card, triple, quadruple check, and then you go Control-Shift-X. Now this is an advanced menu. So we're going to set our host name. So I'm going to set mine to Octopi 2 because I've already got one Octopi. So you can just set it, call it octopi.local. The other important thing is to configure the Wi-Fi. So make sure it is on the same Wi-Fi network as the computer you're going to use to control your Raspberry Pi. Enter the password and then set up any other location settings. Everything else is going to be pretty basic. You don't need to have everything. The main thing you need is the host name to recognize what your Octopi is going to be called, and the Wi-Fi settings. Those are the most important things. Hit save and then click write. All existing data on the SD card will be erased. Are you sure you want to continue? Yes. So while you are installing the Raspberry Pi, you might get some prompts to ask you to format your SD card or eject your SD card or anything like that. You just have to ignore everything, close everything. Do not let yourself format it afterwards, because this is a special operating system on the SD card, and if you reformat it again, then you'll have to restart this whole imaging process. Here we are. So Octopi has been written to the SD card. You can now remove the SD card from the reader. So what we do, we click continue. Okay, just ejecting. All right, we get our SD card out of our SD card adapter, and then we plug it into the back of our Raspberry Pi like so. Okay. And now let's attach the camera. So here is our camera. Now we've 3D printed some holders. So here we're going to put the camera into this holding mount. Like that. Well, actually, we'll put this into, we'll attach our camera to the cable first, I think. So here in the back of the camera, if it's already got a ribbon cable attached, you can detach it by pulling out very carefully this black tab. So I've broken a few black tabs before by pulling it too hard, so you have to pull it out very gently to detach the cable. And then here's the new ribbon cable. This is the longer one, so we put it in very carefully. And then once it's in, you push the black tab back into position. Oops, not fully in. Doesn't look quite straight to me. Hold on for a second. Go. All right, so that's attached properly. We're going to put this on the back of our camera holder first. The back of our camera holder. Like that. And then we attach the front of the camera holder. So make sure it's the right way up. Should be a very snug fit. Okay, so the other parts of the camera holder look like this, and that all attaches to the main arm of this, like so. Okay. Alright, so that's our camera holder. With the ribbon cable, we're going to try to make it so with the ribbon cable, we're going to put it into the Raspberry Pi like so. Okay, so our Raspberry Pi is going to be attached to the bottom of this Raspberry Pi holder. So push all the ports into the side, make sure it's all married up nicely. Oop. So the SD card was actually bumping into the way. So I'm going to take out the SD card first. Make sure that the okay, everything is nice and snug. Here we go. Now it's all in. Okay, we put in the SD card. And then we're going to feed this ribbon cable through this last hole over here. Going to feed this ribbon cable through. And then we're going to attach the ribbon cable to our Raspberry Pi. There we go. Alright, finally. Okay, so we've attached the cable. Now, in retrospect, I should probably have attached that side of the cable first. Okay, let's have a look. So now I can attach this quite snugly and slide it into place. There we are. All right. So now we got both of our main components already set up. So we got the Raspberry Pi, we got the ribbon cable that's connected to our camera. All we have to do now is install the camera to the print bed, and we can put the Raspberry Pi on the side of our 3D printer. So first thing is we attach the camera holder to the front of your 3D printer. Make sure that if you undo any screws that you need to re-level the bed afterwards. And then you plug in the power source for your Raspberry Pi, and then you turn on both your 3D printer and the Raspberry Pi. After that, we're going to have to connect your Raspberry Pi with the 3D printer using the USB cable. Okay, so now it looks like all our hardware is set up. So our Raspberry Pi is connected to the 3D printer using a USB cable. They all have power, and our cameras are set up, and all of our ribbon cables are connected as well. So now, as long as you've set up your wireless settings correctly, then your Raspberry Pi should be connected to your Wi-Fi network after you've powered them both up for a couple of minutes. You can find the IP address of your Pi by checking the connected devices on your Wi-Fi's control panel. Now, every Wi-Fi and router is slightly different, so look for your Wi-Fi router's manual to see how you can go into the control settings. So find the address of your Octopi. In my case, it's 10.0.0.30. And here you're going to do your startup. So here we just go next. We don't need to do any restoring backups. access control. Choose something that you can remember, so don't look at my password. Create the account. Then we hit next. So you press these test, host and port buttons. Make sure everything is reachable. Then I like to enable the connectivity check and then hit next. I like to enable anonymous usage tracking just to help developers with their improvement of Octopi. Hit next and enable plugin blacklists. Press next again. Now this is our default printer, so make sure that you enter the details that are suitable for your printer. So mine is a Ender 3 V2. Ender 3 V2. Put in whatever details are for you. The width of my print volume is 220 by 220 by 250. Axes, no, don't need to change that. Nozzle diameter looks good. Hit next, and then we finish. Now it's worth mentioning that although we're using Octopi just for making time lapses, Octoprint on its own is still an incredibly useful tool for monitoring and managing your 3D printer. Using Octoprint, you can start or stop prints, you can check your printer temperature, and of course keep an eye on the print whilst you're still sitting at your desk. So it's really, really helpful. And there are even plugins to allow you to monitor your 3D printer while you're away from your network, or to send you an alert if the camera detects that it's turning into spaghetti or there's some sort of error in your print. So definitely check those features out when you have time. But now that we are inside Octoprint, we're going to press this connect button to connect with our 3D printer. It says it's operational, but we have some firmware updates that you need to make. So if you're using an Ender 3 like I am, make sure that you follow these next steps, okay? We need to update our firmware before we go any further, because otherwise it's going to make some errors on your print. So let's go into your system settings. Let's go down to Plugin Manager and search for Creality. Whoops, sorry. Press Get More, and then search for Creality. So here are two fixes that need to happen on your Creality 3D printers. So like I said, if you're using a different 3D printer, you probably won't need these, but with the Creality 3D printers, you need to install these. Okay, so hit the install button for the first plugin. Done. All right, that's good. And then hit the install button for the second plugin. Done. All good. So it says that we need to reconnect the printer in order to see the effect changed. But the third thing that we need is the Octolapse plugin. So Octolapse is the plugin we're using to create our cool time lapses. So we'll install that. So one thing to note is that now that we have installed Octopi and Octoprint onto your 3D printer, you won't actually put your files on an SD card and then load it onto your printer anymore. As long as your Raspberry Pi is connected to your 3D printer, you're going to use this new method where we're going to load the files remotely from our computer to our 3D printer. All right, now it's all done. So now we restart Octoprint, and then we're going to check our cameras to see if everything's working properly. After a couple of minutes, you can press the Reload Now button just to see if everything is now smooth. Okay, so here's the Octoprint interface. Click on Connect. And now it looks like it's operational. See how it says operational in the state here? And then we can click on control, and then you'll see that we are now getting a live feed from my camera. Now I haven't set up my lighting on my 3D printer yet, but it's going to look really good. If you see that it is working, then we can now get ready to load a fresh print. So it looks like it's working. I'm going to adjust the lighting at my printer just to get it so that it's a bit clearer. Okay, now you can see that the lighting is a little bit clearer. When you hit the control tab, then you'll see the live feed of your camera. And then you can also do all sorts of other stuff. You can turn the motors on and off, turn the fans on and off here. You can also look at your G-code, your live layers of your G-code. And then over here, Octolapse, this is what we're interested in. So our Octolapse settings are going to be really important to be able to get your Octolapse effect to work. So what Octolapse does in order to create some cool time lapses is that it ensures that after each fixed amount of intervals, like every layer or every few layers, that it moves the print head to a certain position, and it moves the platform to a certain position before it takes the photo. That's how it gets this cool growing effect. But that can also cause some artifacts on your print, because if you can imagine that halfway through each print or several times through the print, it's going to move the print head away to a different location, and it's going to move the platform around. So if your filament is oozing, or if you're not setting up your retraction settings properly, then it can cause some issues. So here we're going to set up our current run configuration. I'm going to select our printer. I'm going to go Creality 3D. And then I'm going to choose Ender 3. And it's going to update my settings from the server. So yeah, okay. Click Save. Okay, so that was easy. In the past, you could you'd have to add your details separately, but it looks like it's going to be good now. Looks pretty straightforward. Let's load up a simple model to test our print. So the new way that we're going to load these files is here. So we press Upload, and then I'm going to put in the Benchy model. Go open. And then here you can see that we have now uploaded Benchy to Octoprint. All we have to do now is press Load and Print, and then we'll see how the first print works. So it says that startup failed. Some slicer settings were missing from a G-code file. Okay, so it looks like I need to also change some settings on my G-code. So hang on there for a second. Hello, this is Mr. Code from the future. So as you can see, Mr. Code from the past is deep in thought while he's trying to solve his slicer settings problem. Basically what you need to do is click on the help button when it pops up with that error, and then it's going to direct you to all the instructions you need to fix the slicer settings. Over here, he's just pasting the code that we need to put into our Cura slicer settings, and then all he has to do is do that basically. So what he's doing now is Mr. Code from the past is copying all the code, pasting it into Notepad++ just to make sure all the formatting is removed, and then he's going into Cura 4.11, which is the version of Cura he is using. Then he is going into his printer settings to add that script into the start of his G-code. Like I said, all of these settings and all of these instructions are inside that help file that he just looked at. So yeah, that's it. That's all he needed to do. So that's it. Mr. Code from the future out. Alright, I hope everybody got their slicer settings fixed, but before we look at our time lapses, I want to talk about the sponsor of today's video, Cura. When it comes to 3D printing, our school is always reaching out to the experts at Cura. They are the leading DIY electronics retailer in Australia and New Zealand with over 110 stores. So if you're in Australia or New Zealand and you want to buy 3D printing supplies like the exotic filament shown in today's video, then make sure you check out their range and visit the Cura website or pop into a store near you. Let's have a look at some time lapses. So here is our first Octolapse, and I'm using the e-silk wood filament from Cura to create this baby Groot model, and the model looks fantastic, but the camera seems to be a little bit blurry. One thing I forgot to do was adjust the focus of the camera, because the camera for the Raspberry Pi is not an auto-focusing camera. You need to use this white ring that comes with the camera to adjust the focus. So once I set that, then the next thing I needed to do was increase the resolution of my camera. It's by default it is set at 640 by 480. So to make it better, we're going to have to dive back into the Octopi settings. So we load up the SD card back into the computer and we are looking for this Octopi text document. Open it up with Notepad++. And then there is a line here that says camera equals auto. So here you change it to Raspberry Pi. Then the next thing you do is scroll down until you see, where is it? Here we are, camera_Raspberry_options. So this is just me fiddling around with the settings, but what you need to do is create a line here that says camera_Raspberry_options equals, and then quotation marks, -FPS space 5. This is going to make it 5 frames per second. And then -X, this is the X resolution, and it's 1640. And then -Y is the Y resolution, and it is 1232. And then -quality 100 close quotation marks. So copy all of this down. Make sure that there is no hash in front of it. So you might have a version with camera_Raspberry options already here, but it will have this hash symbol in front of it. So we just need to copy that out, remove the hash symbol, and then you input these values to make sure that your camera has the highest resolution possible. And now that we have fixed the camera settings and the camera's focus, it is time to make some smooth time lapses. And that's it from me today. Thank you so much for watching this tutorial all the way to the end. I hope you enjoyed it, and if you made any cool time-lapse videos, then post a link in the description below. I'll see you again next time. Take care. Bye bye.